All right, in this section, we're going to talk about automating static code analysis with SonarQube. We'll use the terms SonarQube and SonarCloud somewhat interchangeably. We'll explain the difference between the two a little later on. But what we're going to talk about is what static analysis is. We're going to talk about the features that SonarQube gives us. And then we're going to get into, in the next lesson, we're going to get into how to implement this and then how to use all the different features it gives us. Static analysis is the process of evaluating code without executing it. So as you can see from from implementing the tools and the plugins in IntelliJ or Eclipse, depending on what your IDE is, we put in find bugs, we put in check style, we put in SonarLint. Those are all static analysis tools, and they're as close to the action as you can possibly get. You're sitting there writing the code, and you're seeing any issues that pop up based on those things that are being analyzed, and that is the cheapest or least expensive and least embarrassing place to fix those issues is while you're writing the code. Putting a static analysis tool like SonarQube into the flow. So this is an open source software that allows us to perform the static analysis. Putting it into the flow of your build process or your continuous integration process, where it can be sort of your second set of eyes to try to catch issues before they make it to your QA team or before they make it to your production servers. This is another way to really control the cost and the reputation, reputational impact of bugs, because you're going to try to catch these things before they really become major issues. SonarQube will scan the code for you. It identifies the issues during the process of scanning that code. It logs them into a centralized database, and then it provides you with dashboards and some tools to use to be able to manage that code successfully. It supports about 20 languages, either out of the box or with plugins. As you can see, it supports the C-based languages really, really well. We started this course, and we focused this course on Java quality. And so we're going to continue that. We're going to use the same code that we wrote earlier, and we're going to run it through SonarQube in the process of setting this up and looking at the dashboards and everything we have. But as you can see, there are a number of languages supported here, and there are plugins where you can actually get even further support beyond what you're seeing right here. SonarQube can keep track of multiple projects individually, and within each project, you can actually have multiple modules under that project. So however your code is organized, you might have 4 different applications that you're having to support, and each one of those applications might have different Java projects. So if you're looking at Eclipse, you might have 6 different Java projects under there. Those would actually be a module under SonarQube. You can configure it to support all of that, and that way you can really kind of see the hotspots. You can see, if you have like an older component that was written a long time ago or written by somebody that's not here anymore, it could be, kind of thrown together. It could have been something that you just had to crank out over a weekend just to get it done. You could actually see where the issues are, and you could start to work on cleaning those things up. So it gives you some really powerful tools. Those dashboards will give you the overview of that project, and that includes a breakdown of the issues that have been identified and the trends over time. So you can see if you're getting better, you can see if you're getting worse. And in specific areas, you can actually, you can target, you can hone in, and you can focus on getting things cleaned up. There are a number of different measures that SonarQube looks at. We're going to talk about those in detail here in just a second. But as you can see, there are a lot of different things that it's going to cover and a lot of different ways it's going to look at your code. You can set up quality profiles, and this will allow you to customize the rules that you apply. So if you're not concerned about the tabs versus spaces debate, you can actually turn that rule off. You can exclude it from the quality profile, and that way it's not going to hit your technical debt in the future. Quality gates. It'll actually throw a green or a red status based on the issues that are detected. So there are settings within the quality gates that we'll actually take a look at, where you can determine whether you want it to go green or red based on certain criteria. And that becomes helpful because that helps to integrate with your continuous integration. If you introduce one critical bug or one blocking bug, it can actually stop your build process for you so that you don't even build that code. And the build will fail, and then it'll go back. You can set up notifications to go back to the developer that check the code in. So there's all kinds of cool stuff that we can build in here. user interface that SonarQube provides actually allows you to drill down to see the code and the issues in line with the code. So a lot like our IDE, we can actually go in and we can see the line number, and that way it makes it really easy to go back in and fix and to start cleaning those things up. I've also found that it makes it really helpful when you have a developer and you're going to be working on a specific class or a specific method somewhere, and the developer can go in and look at SonarQube and go, okay, I see that there are 15 different issues in this method. So while I'm in here making my changes, I'm going to work on cleaning some of those things up. And that way, over time, if you've got an already established application and you haven't been measuring code quality in this way over the, in the past, once you implement it, you don't have to just start going top to bottom through every single class to clean things up. You can pick things that you're already going to be working on, and you can start to clean them up from that perspective. And then, one of the other features, the key features for SonarQube, is that it integrates tightly with common CI engines and build systems. So if you're using Maven or Ant or Gradle, it's going to plug right in with them. We'll see how we can run Maven tasks in the course of this one of the lessons here in a few minutes. But if you're using Bamboo or you're using Jenkins or you're using some other CI engine, you can actually integrate it directly with that. SonarQube has a number of measures, a number of ways that it looks at the code to tell us what we need to address or what we need to fix. There's a reliability measure, how many bugs are in the code and what's the severity. So it'll categorize bugs as major, minor, critical, informational, those types of severities for those bugs. And the reliability is a measurement of how many you have. Maintainability talks about how much technical debt exists within the code. How easy is it to work on? How clean is the code? SonarQube actually assigns, as you introduce technical debt, it actually, depending on the rule that's validated, assigns a number of minutes that it should take to clean that particular thing up. And then it'll sum all of that up for you. So you can see you have 5 days of technical debt within this application. And that gives you a good idea or a good feel. I found that it's usually probably a little overestimated in a lot of cases, but it gives you a basis for measurement, which is important. Security, it'll talk about the number of vulnerabilities that exist within the code, and those are based on a couple of different standards. And I'll give you a link in the handout section of the course where you can actually go read about reliability, maintainability, security, and all of the measures that we're talking about. There's a definition on the SonarQube website for that. Complexity. So how difficult the code is to understand. If you have a very high cyclomatic complexity, that's usually the code where it's 3 o'clock in the morning and it's broken and it's an if statement with 10 different conditions, and then there are 4 nested if statements beyond that, and you're just sitting here going, what in the world is this code supposed to do? You get your pen and paper out and you're trying to write down if this then that. And these are things where you should really be asking, can we simplify this control structure? Can we simplify the code so that it's easier to understand and that we can get a grasp on it much quicker? And that also helps you to write better code, because when you have a lot of complexity in your code and you're trying to make a lot of different decisions, you want to make a change to it. Well, now you have a lot of different variables and a lot of different ways to test that you have to keep in consideration. Documentation. Do you have meaningful comments within the code? It'll also count code that's been commented out. But as you can see, as you have seen with some of our other tools, they're going to encourage you to remove commented out code. Duplications, the number of duplicated lines in the code. If you can consolidate, if you can encapsulate that somewhere else, this particular piece will help you to see where that duplication is occurring, and then you can make some decisions about, do I go move this logic into a method somewhere so that I'm not duplicating large chunks of code within my application. And then there's also a section on coverage. We're not going to really talk a whole lot about this, but this is test coverage. How many lines or how many conditions are covered by unit testing? How much of the code is being exercised during our unit testing? So that's a measurement that's there, even though we're not really going to spend a lot of time talking about this in this course. SonarCloud. So SonarQube is installed and it's configured on your own server. So it's open source. You can download it. You can install it. You actually have to do a lot of work to get this up and running. It has its advantages. So if you're on a sort of closed network and everything, your entire development infrastructure is on your network, maybe you're running a Git or a Subversion repository that's behind the firewall, or something else, you really want to control that very tightly, you can install SonarQube and you can configure it on your own. It's going to save you some money because you're not going to have some monthly fees or anything like that. But it is a lot of work. SonarCloud, on the other hand, is software as a service. It's a whole lot less work. You don't have any servers. You don't have any infrastructure to worry about. It is free if you have an open source project. And keep in mind that if you go this route, your code is going to be visible to anybody that logs in to start looking at the SonarQube project in SonarCloud. If you don't want that to be the case, you can do a private project. In private projects, there's actually a monthly cost that's based on the line count within your project. So if we jump over and we take a look at the SonarCloud website, sonarcloud.io, we can see that it starts at €5 per month for private projects, and it's based on the line count. So if you have 250,000 lines, which is a lot of code depending on the language that you're using, but 250,000 lines is a lot of functionality. That's going to be €75 per month. We could just jump over and take a look how much in dollars is that going to cost, and as of right now, you want to keep an eye on this because the currency exchange rates fluctuate, but $88 or so to do 250,000 lines of code being managed by SonarCloud. So there's some cost to it, but it's also going to take a lot of headache off of you. For the remainder of this course, we're going to use SonarCloud. We're actually going to use the open source side of things, but we're going to use SonarCloud and demonstrate how to get that up and running, how to set that up. And in a future course, we'll talk about how to install SonarQube if you want to do just an internal installation. All right, so let's get into it now.